Why, hello, friends! Jen Foxbot here. Welcome to another edition of Math Mondays. Da 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 da. Yeah! All right, in this episode, we are going to tackle two related questions. Number one, what is velocity? What? And number two, what is acceleration? So, most of us have heard these words, but let's define them and look at them in math terms because it will really help us understand what they mean. So, velocity. Velocity is different than speed. And the reason is because velocity is a vector. And vectors are numbers that have a magnitude or size and a direction. So speed is just a magnitude. We could say that our speed is 60 miles an hour, but if we were to define our velocity, we would have to say that our velocity was 60 miles an hour north or 60 miles an hour west. Those are very different quantities, right? If you're trying to get to your friend's house, the direction is important. Your friend might not care about the speed at which you get to their house, but they definitely care about the direction. So velocity is defined to be the change in position over the change in time. If we're looking at this outside of calculus, we can write that by a little triangle. Change in position over change in time. And what this triangle means is that we are subtracting our final position minus our starting position, where F stands for final and I stands for initial. And then we divide that by the time that we arrived minus the time that we started. So in this case, our position is a vector because we are traveling in a specific direction. If we were to look at this in terms of calculus, so we use calculus when we don't have nice discrete chunks of things, but it's basically the same thing. We're just saying, okay, well, it's the change in our position over the change in time. The faster the velocity, the more distance we are covering in the same amount of time. Or conversely, we could also say that a faster velocity means that we're covering the same distance in less time. So if we travel 60 miles an hour to our friend's house, we get there faster than if we are traveling 20 miles an hour. Acceleration is also a vector, so it also has a magnitude or size as well as a direction. And acceleration is defined to be the change in velocity over the change in time. So again, we can do the change in velocity divided by the change in time, or v final minus v initial, and these are all vectors, divided by t final minus t initial. And if we were to look at this in terms of calculus, we would just say, okay, well, it's the derivative with respect to velocity divided by or the derivative of velocity with respect to time. So we are taking the derivative of velocity, and the variable we are taking the derivative with respect to is time. But you can also write this as the second derivative of position. So d squared x divided by dt squared. And again, that is a vector. So acceleration is a little bit less intuitive than velocity, but I think that it helps me understand it most when I'm driving around my dog, because my dog's not very good at dealing with changes in acceleration in the car. So we're sitting there and we're cruising along going at constant speed, and the dog's hanging out like, all right, I'm good. But as soon as I hit the brake a little bit or push on the acceleration, the gas, he starts to move and wobble and have a little bit of a hard time standing up. And so that is when we are accelerating. And if you really pay attention very carefully, maybe if you're a passenger in the car and not focusing on driving, you can actually feel it in your body. So our body wants to resist changes in motion, both when we're speeding up, slowing down, and when we're turning or changing our direction. So if you close your eyes, you can feel if you're turning left, your body wants to keep going forward. So you're going to feel a pull to your right. And if you're slowing down, your body wants to keep going forward, so you're going to feel a force in the opposite direction. If you want to really test this, you can get a balloon and fill it with helium and hold onto it in the car, and then you can see how the acceleration is changing as you're driving around. Cool. All right. So really quick, a faster acceleration means that your velocity is increasing more, and a slower acceleration means your velocity is increasing less. Positive acceleration means that you're speeding up. Negative acceleration means that you're slowing down. And then there's also changes in direction. Didn't really talk about that too much, but that's pretty much it. So velocity is a vector, which is the change in position over time. And acceleration is also a vector, which is the change in velocity over time. Cool, that's it. Let me know if you have any questions or if there are specific problems that you want me to tackle with acceleration or velocity. And if you have any other math questions, we can tackle them together. Thanks very much for watching, and we'll see you next time. Bye!